Welcome to our video lesson on exponents. Now we've briefly talked about exponents before, and I know some of you have even asked me about them, but the idea behind an exponent is, an exponent are these numbers up to the top. And when we have a number to the exponent, what it really means is that number multiplied by itself the number of times that are up here. So for example, here we have 4 to the power of 3. That is equal to 4 times 4 times 4. So 4 times itself 3 times. Well, 4 times 4 is 8. And 8 times 4 is 64. So 4 to the power of 3 is equal to 64. Let's do the same thing with 1 to the power of 5. That means 1 times itself 5 times. So that means 1 times 1 times 1 times 1 times 1, and that's equal to 1. Okay, let's do this last example together. Here we have 3 to the power of 2. Now that's not 3 times 2. Sometimes people make that mistake in thinking that this is 3 times 2, but that's not it. It's 3 times itself twice, so it's 3 times 3. Now 3 times 3 is 9, so that means that 3 to the power of 2 is 9. Okay, when you first learned about multiplication, you probably represented multiplication using repeated addition in groups. Well, exponent operations can be represented by repeated multiplication. Let's look at some of the rules for exponents. So here we have this big B and this big N. That's to teach you some of the key terms that we're going to work with exponents. The first key term we'll look at is the word for this letter B. Now it's funny that it's a B, but this B represents the numbers that are at the bottom. So in our examples here, the 4, the 1, and the 3. The B, what we used to call that term is the base. So in each of my examples, the bases are 4, 1, and 3. The number up top, the N, which I've actually already highlighted in red, the N is the power. So the exponent that it's 2 is called the power. So in our example, 3, 5, and 2 are the powers. Now this basically means B multiplied by itself N times. Some people make mistakes in this topic because they forget to multiply it by itself. So that's a really important idea over there, that it's being multiplied by itself. Okay, now we're going to go into some special rules. There's 3 really important rules. Any number to the 0 power. So for example, if I had 4 to the power of 0, that is actually equal to 1. 5 to the power of 0 is equal to 1. If I have 1,000 to the power of 0, it's equal to 1. So any number to the power of 0 is equal to 1. Any number to the power of 1 is itself. So if you think about it, 4 to the power of 1 means 4 1 times, which is equal to 4. Same thing with 1,000. 1,000 to the power of 1 is 1,000 one time, which is just 1,000. Okay, I want to come back to this last rule later. One last thing. When we say an exponent out loud, we call it a number. So this is a very specific rule for 2 special exponents. When we have a number to the power of 2, we call it squared. When we call it to a power of 3, we call it cubed. We'll talk about why that is a little later, but for now, if you hear someone say something squared, or maybe I'll say it, something squared, it means to the power of 2, and something cubed means to the power of 3. Okay, let's try some examples down here. It says simplify each expression. We have 2 to the power of 5. Well, I know that means 2 times 2 times 2 times 2 times 2. So 2, 5 times. 1, 2, 3, 4, 5. Well, 2 times 2 is 4 times, so I've done these two. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 will give me 32. Hopefully you were able to make that fit on your note. I'm going to squish it down so it'll fit here. Okay, now we're going to do the same thing with 5 to the power of 3. That is equal to 5 times 5 times 5, because we have it 3 times. Now 5 times 5 is 25. So 25 times 5 is actually 125. So that means 5 to the power of 3 is 125. Okay, now we have 10 to the power of 3. That's 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. So 10 to the power of 3 is 1,000. Here we have a nice one, 12 to the power of 1. 12 to the power of 1, any number to the power of 1, our rule right here, is itself. So this is just 12. Now, let's look at these. Let's look at this 10 to the power of 3 and see if we can see a pattern that will help us. We have 3 zeros here, and we have this to the power of 3. I wonder if we can apply that with other ones. If 10 to the power of 5 would be a 1 with 5 zeros. Let's check it and see if it's right. So this is equal to 10 times 10 times 10 times 10 times 10. 10 times 10 is 100. Times 10 would be 1,000. Times 10 is 10,000. And times 10 is 100,000. So the nice thing about anything to the base of 10 with an exponent is that it's just going to be the 1 and that many zeros. So powers of 10, that's my rule over here, will only contain ones and zeros. So this 3 looks really hard. It'd be 10 times 10 times 10 times 10, 13 times, which is a lot. But we just found the trick. The trick is that it's the number of times written there. So this means we have a 1 with 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, now I'd add all my commas in there so that it makes sense. And then we're done this one. Okay, at the bottom of your note, there's this beware thing. You can put a line through it because we're actually not going to talk about that. Take some time to review your note and make it pretty. Spend some time doodling it, filling it in. And then afterwards, start trying the practice. Let me know if you have any questions about this. I'm here to help you. That's all for now. I'll talk to you later.